So let's go ahead and finish 5.3, which we left off. We had just finished the expand and simplify of logs. So now we'll do the combine into a single logarithm and simplify. Okay? So we're combining and simplifying. So first, if we have 4 log base 7 of x plus 1/3 log base 7 of y, what is our first thought here? Can we go ahead and combine them right away into a single log? What do we think?
Are we looking at the 7s?
Yes.
Or
The 7s do indicate that they can get combined. However,
X
the
and Y.
coefficients tell us not yet, right? They don't have the same coefficient. Okay? But basically, if they have a coefficient, go ahead and move them to become what? When we move a coefficient on a log, what do they become? Exponents. So that means, how do we change this? We then have log base 7 of x to the 4th. And it's just the x that's to the 4th, not the whole log base 7 of x, right? That's completely different. We can't touch that exponent. Only exponents on the stuff inside of the log can we get to. Does that make sense? Okay, so if we had log of 4 squared, we can't move that down out front. But if we had log of 4 squared, where the 4 is the squared part, and it's inside, that we can move to the front. This, we can't. Okay? All right, so after that little tangent, what do we do then with the other term? We get log base 7 of y to the
-3?
well, we don't want to make it a negative exponent, because actually it's not, right? Because 1/3 would be 3 to the -1, not -3, right? That's how we change that, right? So all this is just 1 to the, or y to the 1/3. What does that become? How do we change that? When we have a fraction exponent, that means it's a cube root. It's a root. Yeah. So then we have log base 7 of x to the 4th plus log base 7 of the cube root of y. Now what? We want to combine to be one single log. That's the goal for all of these, is combining and simplifying. So, they both have base 7, which we noticed earlier. What does it mean when we add 2 logs of the same base? We multiply what? The whole thing or the insides? Just the insides. So we get log base 7 of x to the 4th times the cube root of y. Okay? Do we see how that worked? Kind of? Do you remember those rules that we did on Tuesday? Okay. Then, next, if we have log of 20 plus log of 5. So, where do we go from here? First thought, do they have coefficients? And do they have the same base? Right? base?
10.
An understood 10. Whenever it's not there, it's understood to be just 10. They don't have coefficients, right? It's just an understood 1. So, can we just go right into combining them? Yeah. Mm-hmm. So that's log of what? 20 times 5, which is
100.
100. Can we simplify that more? Yes, right? Because what does the log ask again? Saying what exponent gives us this answer, right? So 10 to what power gives 100? 2. So the answer is just 2. Log base 10 of 100, right, is saying 10 to what equals 100? 10 squared equals 100. So the answer to this whole thing is just 2. Okay? All right, so now that we've expanded last time, and now we've combined, what we want to do is solve logarithmic equations for a variable, generally for x. So we want to solve for x. First, if we have log base 7 of the square root of x equals log base 7 of 4. So, remember when we learned the rule, if we have b to the u equals b to the v, then u equals v, right? This is the same kind of thought here. Same base of the log equals same base log, right? Then their insides have to equal. So this kind of translates into log base b of u equals log base b of v, then u equals v. Okay, it gives us the same kind of thing. However, this is only when it's a single log. Okay, so if you have a separate log, even if it's the same base, we can't go directly into this. You have to combine it, just like we did on the last one, into a single log on each side. Okay? So, we have that case here, right? Because we have log base 7 of something equals log base 7 of something. So we just go straight into the square root of x equals 4. That's it. And then, well, we finish solving for x, of course. So what do?
Square root.
Square both sides. Does that give us a plus or minus? No. Only when we do the square root. So squaring gets rid of negatives, right? That's why square rooting has to give us the possibility of a negative. Okay, so it's only the one direction. That's why the square root is not a perfect inverse of the square. Right? But, because remember, the parabola does not pass what test? Horizontal line test. So it doesn't have a true inverse. Right? That's a function, at least. Okay, sorry, I'm like already kind of going into final mode of connecting things. And all right, so that means we have x equals 16. Now, I would suggest, right, always going back and checking that it works in the very original problem. Because if you get multiple answers here, maybe we got, let's just pretend we got a -1 as an answer. Can we plug that in? No. Like double no, because, well, we can't take a square root of a negative number, and we can't take a log of a negative number, right? So it's like a double no. So you have to check to see if your answer is valid. Because even if you only get one thing, it could just be no solution. That is an option. Not all equations that we may give you have solutions. All right, second one is if we have log base 4 of 2x plus 1 equals log base 4 of 13. So what do?
2x plus 1 equals 13.
We have logs, same base, so their insides equal. So 2x plus 1 equals 13. And then finish solving for x, right? So what do we do first? Subtract 1. So 2x equals 12. So then x equals 6. Does this work? 2 times 6 is 12 plus 1 is 13. 13 is valid to have in here, right? Okay. So then, I didn't make myself enough room on it because I have a C. Is it okay if I erase this now? Okay, because then I can put C in here and they can be all together, just a little backwards. All right, so then if we have log base 9 of x plus 12 minus log base 9 of x plus 5, but then I didn't make myself enough room still, equals log base 9 of x. So now we have a little bit more to do, because remember, with the theory I said, we cannot have separate logs on one side, even if they're same base. We have to combine it into a single thing. So how do we combine that? We could. You could move this one to the other side if you don't want to have division, right? Because a minus means we divide the insides, right? Remember, that's the second property of logs. So you could add it to the other side and just have multiplication then. You'll get the same thing either way, because if we divide it, we end up with a fraction and you have to multiply it to the other side in the end anyway. So it really doesn't matter. So we can go ahead and add it over. We have log base 9 of x plus 12 equals log base 9 of x plus log base 9 of x plus 5. So now what? Log base 9 of x plus 12 equals log base 9 of what? X plus 5 times x, or x times x plus 5, doesn't really matter. Or we can go ahead and multiply it through. What would that be? X squared plus 5x. So now what? We have same single log, same base, so the inside's equal. X plus 12 equals x squared plus 5x. Good?
You switched it to get rid of the minus?
Yeah. Well, because then we're multiplying instead of dividing. It doesn't matter. You'd get the same answer either way. But if you don't like dividing things, then sure, add it over to the other side. Doesn't hurt anything. It's just doing it first versus last. Okay. So, what now?
You just solve it now?
Yeah.
Just minus x, you minus x from the left
Yep.
side there.
Get everything on the same side. Go to the positive x squared side. So then 0 equals x squared
Plus 4x.
plus 4x
Plus 12. Well, minus 12.
minus 12. How does this factor?
2 and 6.
6 and 2, so x and 6 and x and 2. Positive 4, so which one's positive? 6, so plus 6 minus 2. So then x is equal to negative 6 and positive 2. Do they both work? Can we plug in -6 everywhere? This one right here tells us no, right? Because we cannot plug in a negative into a log, right? Can't take the log of a negative number. On these, this one, it's no good either. This one, it works, but all of them have to work for it to be a valid answer. So -6 doesn't work. What about 2? Does 2 work everywhere? Well, 2 plus 12 is 14, positive, cool. 2 plus 5, 7, positive, good. And just 2, positive. Perfectly okay. This is not saying that all negative answers are bad, because if we just had, right, like things like this one, then the -6 would be fine. It's just that the end result of what you're taking the log of has to be positive, not just your x values, okay? Yes, kind of, more or less. All right, so that is 5.3. That was the last little bit that we had to do. So, are there any questions in the homework from either 5.2 or 5.3? Anything?
Wait, question.
Yeah.
When you plug in the 2 for 2 plus 12, 14 minus 7, you don't get 2 though. I don't get it.
What do you mean?
If
No, you don't
plug it into
subtract
the-
these.
Oh.
We don't subtract these. So log of base 9 of 14, it's a decimal. I have no idea what it is.
Yeah.
Minus log base 9 of 7, again, it's a decimal, I have no idea what it is. And then equals log base 9 of 2, apparently. Whatever those decimals are, they will add together to be pretty much the same, with maybe a rounding error here or there, depending on what decimal place you keep to. Okay, does that make sense? Okay. All right, so a log, I always kind of think about it as like a square, like a root, okay? The stuff inside of it, you can't get to. You can't distribute the log, you can't get to it, because it's inside of the log, like it's inside of the root, okay? So, think about it like that. It's packed in there, we can't get to it. The only time we can get to it is if we have another log, because with the same base, then we can somehow combine it, or coefficients can become exponents and do things, or we can transfer from a log to an exponential. Can go back into its inverse, right, and flip it around. So that's the only way to kind of affect the inside of a logarithm, okay? Okay, so back to any homework questions. Anything from 5.2? That's the exponentials, right? Isn't it? Yeah, I think so. I'll go ahead and erase all of this out. Any of these that were weird or anything? Just tell me to stop if you see something. how to cancel out the inverses when they're like this? Yeah?
It'll be just 5.
It would just be 5 because it looks bigger on my screen. Is that more or less? Okay. So when we have something like this, just look at the bases, right? And remember that this 6 is an exponential function. So the log, to cancel with it, has to be where the variable goes, right? So yes, they're same base, but I mean, we could have 6 times log 6 of 5, and this does not cancel because that's just multiplication. The log is not within the exponential function, right? So it's the same idea. Remember, I just said that logs are like roots, that if we have the square root of x squared, it cancels, right? Because the square is inside of the root. Or if we have the square root of x squared, then the root is inside of the square, right? So that's how they work with each other. They have to be inside, one versus inside the other, right? So that's why this doesn't work, because the log is not within the exponential function. Because the log base 6 is within the exponent of the 6, we can just cancel these two, and then the inside of the log drops down as your answer. Does that help? Okay. So then the inverse of that, the converse kind of, if we have log base 6 of 6 to the 5th, right? That is 6 to the 5th, an exponential inside of the log, right? Okay, so again, if we just had like log base 6 of 6 times 5, well, that doesn't cancel the 6, okay, and just leave you with 5. It's because the 5 is in the exponent, and then the exponential thing is inside of the log with the same bases both times. That's how logs and exponentials have to cancel. You have to have a log, and you have to have an exponential. Okay? All right. Well, I should probably erase this now so then you can see the next problem that comes up. I should turn this so that anybody watching can actually see. Okay. So then this one is the opposite, right? We have an understood exponential because it's just to the first power, right? Inside of a log, same base. Right, so we can cancel, and the answer to this would just be 1. Yes? Make sense?
Is that the log with 8 to the power, or is that 8?
It's, so you're never going to have a base to a power, okay? Assume the thing next to it that's bigger is inside the log, okay? Because for the log to be valid, there has to be something inside of it. Okay, so just assume that that's inside of it. I'm not saying you can't have something to a power as a base, but you don't really see that often, and not in this class. Okay. Okay, and then this one we're just evaluating, right? So again, we're asking, what is the answer, right? What is the exponent that gives us this answer? Okay, so like that, right? So it's log base 8 of 8 8 to the negative 8. So log base 8 and the 8 as the base inside cancel to leave you just with the exponent of negative 8. So which direction does a logarithmic function go in? Do we remember? So what does an exponential function look like? Do we remember? Just a regular thing, so if I just drew that, that's a regular thing, right? An increased curve. Well, that's kind of like an exponential, right? So, exponential is like that. Logarithmic is kind of the opposite way of doing an increasing curve. Right? And they meet up around the kind of X line, right? So, a basic kind of graph like this is what the log looks like. However, there's, oh, no, actually, yeah. So, this doesn't work if I have it this big. Hold on, let me, that's better. We have these 4 graphs. What are all these coming from, right? This one is the reflection of a logarithm, right? So we flipped it around the x-axis, so that means the negative was where? In with the x or outside? Outside. So the axis it flips is not where the negative is. So this is negative log base 2 of x. This one is what? Exponential or logarithm? It's exponential. And is it the regular or the reflection? Reflection, because it's going down, right? It's decreasing. So this would be, it's flipped around the y-axis, so that means it's a negative with or outside, with the x or outside. With the x, because again, right, we flipped around the y, so that means it's negative x. So this is e to the negative x kind of thing. Well, not exactly, not e, but 2 in this case, because we're base 2. Then this one is the log function, right? And this is regular exponential. Yeah? So if we can somewhat at least identify these a little bit, then that can help eliminate, because we pretty much just said it has to be this one. However, you can plug in the points that they give you, right? Plug in the x, see if it works. Okay, so like what I'm saying here is if we do log base 2 of 2, what exponent on 2 would give us 2? 1. Plug in 2, get 1. Okay, that one works. Log base 2 of 1, what exponent on 2 gives 1? 0. That's the output. Okay, log base 2 of 1/2, what exponent on 2 gives 1/2? -1, because we moved it to the denominator, right? So that's a negative exponent. And it's still just 2, so that's why it's a 1. If it was log base 2 of 1/4, -2, because we moved it and we squared it, right? Okay, so this one, I just made that one up. All 3 of these points are on this graph, so that would be our graph to choose, right? And then what else? What is the normal domain of a logarithm function? Positive numbers. So bigger than 0. 0 to infinity, not inclusive. So, how do we figure out the domain of this function? I think I heard it. Say it louder. Not equal, but greater than. Just greater than, right? Not greater than or equal to. That's a root. So that's the one difference between roots and logs. Can't be 0. Same thing on this one. Same things on that one. Okay. And then this is the one that we just finished. So how could we go about figuring out which one of these is our answer? What could work here? What could we do to log base 4 of 16x to get towards one of these? Well, we can't cancel it out because of the x. So if we don't like the things together, let's split them up, right? How do we split up? We would split and add because they're being multiplied. So that would be log base 4 of 16, or we said that was 4 squared, but yeah, we'll get to that, plus log base 4 of x. So then, well, 4 to what power gives us 16? 2. So this whole thing is just 2, so it's 2 plus log base 4 of x, which is b. But looking at just this and this, we would not connect that, right? We wouldn't choose a 2-term thing coming from a 1-term question, right? So you have to remember that logs can separate, okay, from either multiplication or division on the insides into those pieces. That's the big thing with those log properties. It does not make much sense until you get used to it. So again, here we have to see that division on the inside means what on the outside? Subtraction. And remember, this is not the right answer, right? That's the opposite. You subtract the bottom from the top, not the top from the bottom. So it's this one. Okay? So, y'all look exhausted. So, let's say we're done. That's a pretty good review of these last sections. Let's just real quick run through what sections are on this next test. Just really quick. So, what did the last test go through? Do we remember? It included 4-1. And that went all the way up through vertex and parabolas and such. 4.2, however, is the applications. Okay, so it would probably be good to look back over 4.1 and still remember it, because that gives you all the stuff that you need for the applications in 4.2. But 4.2 was the cost and all that fun stuff, right? Cost, revenue, profit, price equation. So remember how to go from price to profit. That's the biggest jump. And remember, price is lowercase, profit is uppercase. Okay. And then 4.3 was polynomials. So polynomial has to have no variables in a denominator, no negative exponents then on variables, no roots on variables, right? Anything is good with the coefficients though. And then we had also highest degree term, and so the degree of the polynomial, the leading coefficient, the constant term, all those fun things. Zeros, right? End behaviors, multiplicities of zeros, what the multiplicity mean, if it's even or odd. So look back at those charts that I did. Let's see then. Then 4.6 was rational functions. And now we're getting into what we just quizzed on yesterday, right? So how to find zeros, domain, range, asymptotes. Okay. 5.1 was exponential functions, the exponent rules, the graph, remembering its domain and range, and it has a horizontal asymptote, and then the, logarithms, and so on, and everything that we just talked about today. Okay, so it's a lot of kind of varied stuff. So make sure to look at everything individually. And I would probably for sure start working on that practice test over this weekend. Okay? Alrighty. We're getting close to the end. We only have 2 more sections. It will go quick. Always does.